Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Till now in similarity we have studied that if two triangles are similar, then the ratios of their corresponding sides is equal. Now in this lecture we will study about ratios of their areas of two similar triangles, right. So for that let me first of all tell you about ratios of their altitudes. So if AM and PN are the altitudes in triangle ABC and PQR. So this angle is obviously 90, this angle is 90, this angle is 90 degrees, this angle is 90 degrees. So if for a moment I know that ABC is similar to triangle PQR, then I also know that this angle, angle B is equal to angle Q, right. So if these two angles are equal, then look at these two triangles ABM and PQN. In these two triangles, this angle is equal to this angle is 90, so this angle is also 90. Hence, triangle ABM is similar to triangle PQN, and by this similarity I can say AB by PQ is equal to AM by PN. And what is AB by PQ? It is ratio of corresponding sides of these two triangles. So the ratios of corresponding sides of two similar triangles, that is AB by PQ, BC by QR, AC by PR, is also equal to ratios of their altitudes, that is AM by PN. Okay. Similarly, in similar fashion, you can talk about its median, its angular bisector also. Okay. So let me give you a brief introduction about that also here. Let us say if this triangle and this triangle, these two triangles are similar. So ABC, PQR, these triangles are similar. If I draw an angular bisector here, that is this angle is equal to this angle and another angular bisector here, right. What will happen in these two triangles? Now ABC is similar to PQR, right. We are starting with that. So this angle is equal to this angle and angle A is equal to angle P. So their halves will also be equal, that is this angle will be equal to this angle. So like above I can say this triangle ABD is similar to triangle PQ, let us say M. Again AB by PQ will be equal to AD by PM. This time these are ratios of angular bisectors. Okay. Similarly, in case of medians, let us say these two triangles are similar triangles ABC, PQR, and these are medians. AD is median, PM is also a median. So AD is median, so BD will be equal to DC, and PM being the median, QM will be equal to MR. Now ABC is similar to PQR, ABC is similar to triangle PQR. So I already know that AB by PQ, that is ratio of corresponding sides, are equal, BC by QR, AC by PR, and these angles are also equal, corresponding angles. So if it is alpha, this is also alpha, right. Now focus on these two triangles. AB by PQ is equal to BC by QR. So if it is equal to BC by QR, and if I divide BC by 2, I will have to divide QR by 2 to maintain this ratio. So what is BC by 2? AD is the median, so BC by 2 can be taken as BD and QR by 2 can be taken as QM. Now look at these two triangles. These two triangles are also similar by side angle side similarity criterion. Why? Because AB by PQ is equal to BD by QM, and angle involved or angle included between them is also equal. So these two triangles are similar. Now I can say that AB by PQ is equal to BC by QR equal to AC by PR is also equal to AD by PM, right, because of the similarity of triangles ABD and triangle PQM. AB by PQ is equal to AD by PM. So in two similar triangles, I can make this statement that the ratio of their corresponding sides is equal, and it is equal to ratios of their corresponding altitudes, ratios of their corresponding angular bisectors, ratios of their corresponding medians also, right. Now, I will talk about ratios of their areas. So, what is the area of this triangle? If AM is altitude, then area of triangle ABC is equal to half into BC into AM, right. And what is area of triangle PQR? It is equal to half into base QR into altitude PN, right. Now, I want the ratios of these areas. So, area of triangle ABC and area of triangle PQR. These two triangles are similar, right. So, we are starting with similar triangles here. 1 by 2 will be cancelled. So, BC into AM by QR into PN, right. BC into AM by QR into PN. Look at this, BC into AM by QR into PN. Okay. What can you tell me about BC by QR? This is ratio of sides of ABC and PQR, and these are ratios of altitudes, and these ratios are equal because of this similarity here. Triangle ABM and triangle PQN are similar. I have just proved it, right. So, what I can do here is I can replace AM by PN by BC by QR, or vice versa also. So, if I replace AM by PN by BC by QR, it will give me BC by QR here. So, it is equal to squares, ratio of squares of these sides. So, BC square by QR square, and if I would have replaced BC by QR by AM by PN, it would have given me AM square by PN square, which is obvious because these ratios are anyways equal. So, if I square these will be equal to squares of AM by square of PN. So, areas of ABC by area of PQR, this ratio is equal to ratio of squares of their sides, corresponding sides. This is one takeaway from this. Another takeaway is that the ratio of sides is also equal to ratios of altitudes. So, it is also equal to AM square by PN square, which are the altitudes, and it will also be equal to ratios of squares of angular bisector, corresponding angular bisector, and it will also be equal to ratios of squares of their corresponding medians. Okay. I hope this theorem is clear to you.